Hi, welcome to the channel. Here I post challenging math problem video daily. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today we will discuss about greatest integer function and do few problems. So the greatest integer function is written as box function of x, which denotes the larger integer not exceeding the real number x, which means, say suppose if I write x a number, say 3.142. Okay, so the greatest integer function of x is nothing but the integer value which is less than or equal to x. Okay, if x equal to say 0.123, so the greatest integer function to this number is 0. If I take x as minus 1.3, so the greatest integer function to this number is minus 2. So the graph of this greatest integer function is the value from x, say suppose this is 0, this is 1, then 2, then 3, and so on, and left hand side is minus 1, minus 2, and so on. So if we take any values between 0 and 1, the greatest integer function is always 0. So it start from here and tends to 1, but as it approaches to 1, it will never meet at 1, and as soon as it is 1, so it will jump to this point at x equal to 1, y equal to also 1. So the next, in between 1 and 2, the value is the graph is this. So for 3, the graph in between 2 and 3, the graph is this. So it is like a step function. In between minus 1 and 0, the function is this. Okay, so again, any number x can be written as box x plus fractional part of x. So this is the GIF, greatest integer function, and this is the fractional part of x. So for the fractional part, it is always lies between 0 and 1. Okay, so suppose in this function where x equal to 0.0123, so the fractional part is 0.123. Okay, if x equal to say 2, the fractional part to this value is 0. So similarly, if we plot the graph of fractional part of x, it is simply, since it is 0, then it is 1, 2, 3, this is minus 1, minus 2, so minus 3. So it is like this, and this value is 1. So this is the fraction part of x. Okay, now we will do one problem based on this greatest integer function. So our problem is, say if box x denotes the greatest integer function, okay, then find the value of 1/4 plus 1/4 plus 1/200, then 1 by 4 plus 2 by 200 plus 1 by 4 plus 3 by 200 plus so on. The last value is 1 by 4 divided by 1 by 4 plus 199 by 200. So what we can do is first value is 1 by 4, second value is 200, okay, and this is 51. Next is 52 by 200, third is 53 by 200, and so on. So the last value is, say, this is 200, this is 50 plus 199, so 199 plus 50, this is 9, 249 by 200. So in between these numbers, okay, there are some numbers which will start, say, suppose the first value of this 1 by 4, the greatest value is 0. This is also 0, this is also 0, so it will continue till the value 200, then 201, then 202, and so on up to 249 by 200. Okay, so how many numbers we have? So this first portion is 0. We need not to write 0 every time, so this total terms is 0. First term is 1, then this 201 divided by 200 means 1 plus 1 by 200, so 1 plus 1 by 200 means 1, then again 1, so like that we have 50 ones. So the answer to this question is 50. Okay, second question is, for all real value of x, box x is denoted as GIF, and third, this curly bracket x is represented as fractional part of x, then find all the solution of this equation 13 box x plus 25 fractional part of x equal to 271. So how we can proceed here is, we can write box x is x minus fractional part of x. So we change this x as x minus fractional part of x plus 25 fraction part plus 270. Okay, so we open 13 minus 13 fraction part plus 25 fraction part equal to 271. So what we can do is take this 13x on the other side. So 271 minus 13x, and we have that is 12 fractional part of x. So we can write fractional part of x as 271 minus 13x over 12. Now we have established a relation between fraction part of x and x, and we also know that fraction part of x is always lies between 0 and 1. So we can write this value is lies between 0 and 1. So from this we can easily solve for x. So taking this two component, so what we have here is 271 minus 13x is greater or equal to 0. So 13x equal to 271. So x is less than 271 over 13. Okay. So if we simplify further, so we have this is coming around 84 whole 8 by 13. Okay, and if we take these two components, so 271 minus 13x divided by 12 is less than 1. So 12 is cross multiplied. So 13x is greater than, so this is 259. So x is greater than 259 over 13. Okay. So this is, I think it is coming. I have done some mistakes. It is not 84. It is 20 whole 8 by 13. And this x is greater than 19 whole 2 by 13. Okay. So the value of x lies between this is 19 whole 2 by 13 to 20 whole 8 by 13. This is the range of x. Okay, and this is open bracket. Okay, so this is the range of x. Okay, now the last problem which you can do is solve this, solve the equation. The equation is box x square equal to x square minus x into box x. We have to find the values of x. Okay, so what we can do is we write x as box x plus fraction part of x. No, sorry. We can do here is, you see, what we can do is box x square. We can take x as common. So x, after taking x common, we have x minus box x. Okay. So x can be written as this box x plus fraction part of x, and then x minus box x is fraction part of x. Okay, so we multiply this whole number, so x box x into fractional part of x plus fractional part of x square, and we make this as a quadratic equation. So we have box x square minus box x into fractional part of x, and we will do the other way round. Okay, so what we can do is fractional part of square plus box x into fractional part minus box x square equal to 0. Okay, so this is a quadratic equation in terms of fraction part of x. So using quadratic formula, we can write fraction part of x equal to minus b. So minus b is this, okay, plus minus b square. B square means this square minus 4ac, 4 minus minus plus ac, okay, by 2. So taking fraction part, sorry, box function out, so we have root 5 divided by 2. So box function divided by root 2 and minus 1 plus minus root 4. So this we got. Okay, now we know that again fraction part is lies between 0 and 1. Yes, so 0, we substitute the value of fraction part, sorry, so we have minus 1 plus minus root 5 over 2 is less than 1, taking these two side. So obviously this value is always greater than 0, so fraction part equal to, this is 0 and this is 2 divided by minus 1 plus root 5. Okay, so neglecting the negative value, we just take the positive value, so we neglect the negative value. Okay, so our box function is coming as this. So we further, if we simplify this, so root 2, sorry, 2, this is root 5, plus 1 divided by root 5 minus 1, so it is coming around 4, so 2, 2, 2 is 4. So ultimately our answer has come as root 5 plus 1 by 2. Okay, now this value, this is a integer portion, so root 5 plus 1 by 2 means this value is box function of this value is always 1, because if we take root 5 as 2.23 plus 1 divided by 2, so 3.23 divided by 2, so approximately 1.6. So this value is lies between 0 and 1.6, so the integer part of this x is always 1. So we have found the integer part of x is 1. Now fraction part is, we have this equation, so if we substitute the value of box x, so we have fraction part as root 5 minus 1 by 2. So x equal to greatest integer plus fraction part. So 1 plus root 5 minus 1 by 2. So the value of this complete x is root 5 plus 1 by 2. So this is the final answer. Okay. So this is all for today. See you tomorrow.